Hey everybody, this is the last video of the school year. I'm going to break down how to calculate volume of several shapes here. The first one we're going to look at is going to be a prism. Um, and this strategy is going to be more so the general strategy of finding volume. So for a rectangular prism, to locate the base, because there are now 6 sides on this, the base has to be parallel and congruent to the opposite side. So if I were to look at this side right here, this face, that is going to be parallel and congruent to the other side. And I could pick, and in this special case, you can pick any one of the faces and it's going to be congruent and parallel to the other side. So it's a win-win. Now volume is a third dimension. And I'm going to look at this in terms of slicing this up into 3-dimensional pieces. And I'm going to change this number 10 to 4 because it's going to be easier for the visual. So what you're going to do is you're going to look at, first off, the area of your base. In this case, I know that 4 is also going to be the dimension here. And this area will be 12 inches squared. Now, if I were to slice this into 4 even slices, as even as I can make it here, each one of them is 1 unit. In this case, it's going to be inches. It'll be 1 unit in height. So the height here will be the distance between your two bases. So when we're taking into account the area and the number of areas that are 1 unit high and you stack them, that'll give you the volume of your shape, of your prism or your cylinder. And I'll show you how that works with the cylinder. So in this case, we look at, it's the area of your base times your height. And it's commonly written as capital B for area of your base. If you put lowercase b, that means the length of your base. But capital B means area of your base times your height. So in this case, the area of your base is 12. And your height is 4. That's the number of 1 unit slices from base to base. In which case now our volume will be 48 inches cubed. Because now we took our area, which is inches squared, we multiplied it by one more measurement of inches. So inches squared times inches is inches cubed. And this general strategy works for a cylinder too. In this case, I will use a height of, let's say, well, we'll use 4 again. Okay? And the base is going to be the circle. And on the bottom, there will be a congruent base that is also parallel to it. And you can slice this up into 4 even slices that are 1 unit in height. So the area or the volume here will be the area of your base times your height, which is pi times 3 squared. That's the area of your base times your height, which is, in this case, 4. So that's going to be 9 pi times 4, which is 36 pi. I don't have units here, so I will just put units cubed. Now, for another example here, which is a trapezoidal prism, it's often hard to find the base. If you wanted to say, all right, I'm going to say this is my base right here. Well, that can't be the base because it may be congruent to the opposite side, but it's not parallel to it. If you imagine if I were to just squish this shape over to the left side, it wouldn't fall flat on it. It wouldn't just squish flush up against it. So in this case, the trapezoid is going to be your base, because if you were to squish this directly back, it would be flush up against its congruent shape. It would be parallel to it. So this is my base. And then therefore 3 has to be my height. So if I were to slice this up 3 ways, I would have 3 congruent trapezoids with a height of 3, or height of 1. So area here is going to be the area of your base, which is 1/2 times the height, which is 7, times the sum of your bases, which is 6 plus, see these congruent marks tell us that the top base is the length of 3. So that's the area of our base, and then times your height, which is going to be 3, the number of congruent slices. I'm going to leave the calculation for you. I think we can all handle that. All right, I had some technical difficulties with this video. I'm going to link a video here showing you using water displacement, the volume of a cone in comparison to the cylinder. And the video is going to show you that when a cone and a cylinder have the exact same base and the exact same height, the volume of a cone, and this works with any pyramid, meaning has one base, the volume of the cone is going to be 1/3 the volume of your cylinder. Or, and if it's not a cone, if it's not a circular solid, if it's a prism, what is going to be 1/3 the area of your base times your height. Okay, I'm going to link a video so you can see that in full. And looking at our last shape here, this is volumes of a sphere. I'm going to link another video for this. This is really cool. It's also dealing with water displacement. And what we're looking at here is that the radius of your sphere is going to be r. So that means it's also going to be the radius of your base of your cylinder. And therefore, the height of your cylinder is going to be 2 of those radii. So it'll be 2r. And from the video, the water displacement shows us that in this particular case, the volume of the sphere is going to be 2/3 the volume of the cylinder. And we know how to find the volume of a cylinder. The volume of a cylinder is going to be the area of the base, pi r squared, times your height. In this case, now we know what our height is. Our height is 2r. So I'm going to put 2/3 pi times your radius squared times your height, which is now 2r. And r squared times r will give you r cubed. And then 2 times 2 will give you 4. So the volume of your sphere ends up being 4/3 pi r cubed. And that's the volume of any sphere with radius r. Once again, I'm going to link the videos to show you using water displacement how that 2/3 comes about. And I'm also going to link a video to show you where the 1/3 comes into play in relation to the cylinder. So I hope this is helpful. Please try the practice problems, submit those. That's our last assignment for the school year. Hope you're all well. We'll talk to you soon.